So mathematical applications, geometry and trigonometry. Hello, my name is Mr. George. Always feel free to ask questions. All right, so today we will talk about shapes and their compositions, trigonometry and its applications, and circle theory. So, all right, so shapes recap. So we're just going to go through all of the major shapes. So first of all, we have a circle. It only has one side, and within radially, it has 360 degrees. So if you take a center point right here, right, and then you take all the degrees within one revolution of that center point, it's going to be 360, and that's something very important. So with other shapes, the degrees are actually going to come from the inner angles, right? So here we have a triangle, we have three sides, and the sum of all the degrees is going to be 180, right? So this is going to be a set amount of the degrees. There's going to be a set amount of degrees. It's going to be a set amount of degrees, and they always have to equal 108. All right. And so here we have a square. We have four sides, and here it is equal to 360 degrees, right? Because the square has four corners. What that means is basically it just has four 90-degree angles, right? So 90, 90, 90, 90, 90 times 4 is equal to 360, all right? And we can go on with all the pentagon, the hexagon, and the octagon. But something that I really want you guys to understand here is that, so as the number of sides goes up and the number of inner angles goes up as well, the total sum of the degrees has to go up as well. So here we have 540, and here all the way up to 1080 degrees. So another different way that we can show this is the difference between the different quadrilaterals, right? So a quadrilateral, by definition, is a polygon or a shape with four sides, edges, vertices, and interior angles. So, for example, here we have a square. Now, the requisites for a square is that each square has to have four equal sides of equal length and four right angles, right? So if we look over here at the rectangle, right? So it has four right angles, right? But what does it not have that the square has? Can anyone tell me?
Four equal sides.
It does not have four equal sides. That's very correct. So there we go. It's a little longer on one side. So it has four right angles, but it does not have four equal sides. So for example, here we have the rhombus, right? So it has four equal sides, but it doesn't have four right angles. And so here we go. We have a kite, which is kind of like a different version of it. So it's going to be two pairs of adjacent sides of equal length. So for example, these two are of equal length, these two are of equal length, right? And so another minor requisite is that at least for one pair of sides or one pair of angles, they're going to be the same angle, right? So that's something else. So parallelogram, it's always the only requisite for the parallelogram is going to be that it has to have two pairs of parallel sides. And by proxy, that means that this angle is always going to be equal to the angle opposite of it. Do you guys understand? And this angle equal to the angle opposite of it. All right, so we have a rhombus, right? So rhombus, the only requisite for that is going to be one pair of parallel sides, and a regular, it's just free balling. It does nothing. All right, so here we have a representation of the quadrilateral hierarchy. So for example, here we have a quadrilateral. It's just like a normal thing. There's no real rigid structure to it. But then over here, we have the simple fact that it has two sides that are adjacent and equal to each other. So right there, two pairs. So this side length is going to be equal to this side length. Side length is going to be equal to this side length. And that can also be seen in the rhombus, right? This side length is equal to this side length. This side length is equal to this side length. But also in the parallelogram, it means that it has two pairs of parallel sides, right? And so here it has two pairs of parallel sides and so on, right? And so in trapezoid, all it really requires is that it has one pair of parallel sides, right? But then over here, like this edge is not going to be the same as this edge, but here it's going to have like an equal like inner angle on both sides. And so here we have the descension into the square. So the rectangle has four 90-degree angles, and here it has four 90-degree angles, and all the sides are of equal length. So, and here we have another hierarchical representation. So, and the internal angle formula. Raise your hand if you know what this is or if you've ever heard about it. Has anyone ever heard about this? All right, amazing. So internal.
No.
All right, this is good. All right, so internal angle formula, right? Oh, hello, Setna. I didn't see you join. All right. Feel free to raise your hand or ask any questions if you are not familiar with anything, or if you have any doubts. So, for example, we're going to jump into the internal angle formula. So, to determine the sum of all the terms within a polynomial, we use this formula. The sum of all the terms being all of the inner angles, right? So the sum is going to be equal to n minus 2 times 180. And so n here is the number of sides on the polynomial. So let's go ahead and try this for the triangle, right? We know the total amount of triangle thingies, but that's fine. So we have 3 sides, right? And so we just plug it into this formula, right? So it'd be 3 minus 2 times 180. And so 3 minus 2 is 1, and it's going to be 180 degrees. And so then here we go. We have this hexagon, right? We have 7 sides, and then we're going to plug it in to this same equation. It's going to be 7 minus 2 times 180 degrees, and then that's going to give us 900 degrees. All right. And so who can tell me this is a dodecagon, right? And so this has 12 sides. And then, so who can tell me the sum of all the degrees? Who can do it in their head? And explain the reason. How would you find out the sum of all of the inner angles?
Can I answer?
Yeah, you can answer. Yeah.
Okay. I'm not sure if this is right. Are we just doing what was above, like in our head?
Yeah.
Okay, so I'm guessing it would be, instead of n, we would put 12. So 12 minus 2 would be 10. And then 10 times 180 would be 1,800. So I'm guessing.
Very good. Yeah. So you just 12 minus 2 times 180 is going to be 1,800 degrees. Perfect. All right. So yeah. So this is where it starts to get a little complicated. So how does this help us? So the rule holds that the okay, I gotta put this, I gotta move. So how does this help us, right? So the rule holds that the sum of the angles is constant. And so this means that there are no exceptions. So if we know other measures, we can find unknown angles. So for example, here, if 2 angles of a triangle are 44 degrees and 38 degrees, what is the remaining measurement of the remaining angles measured, right? So let's say this one is 44 degrees and this one's 38 degrees. Does anyone have any idea, any gist of how we would solve this? Any suggestions on how to solve this?
Can I go again?
Yeah, sure, go ahead.
So I think, at least the way I would solve is I would add 44 degrees plus 38 degrees, and I would just subtract that by 180, I think.
44 plus 38, that's very right. Yeah, that's exactly what I would do. All right, so yeah, so it'd be the sum of all angles must be equal to 180 degrees. It's 180 degrees is equal to the 44 plus 38 plus x degrees, and so then you just subtract 44 and 38 from 180, and that would equal x amount of degrees, and so that means that x would be 98 degrees. Very good. Setna, how about you take a look at this next question? All right, so if a quadrilateral has a right angle, right? All right, so a quadrilateral has the right angle, another angle with a measure of 52 degrees. So, all right, so let me say this again. Sorry, I got lost. So if a quadrilateral has a right angle, another angle with a measure of 52 degrees, and its other 2 angles are congruent as in equal in measure to each other, what are the measures of each angle? So how would we go about solving this? Setna?
I'm not very sure.
I'm not very sure. Well, do you have any idea? You can look up at the first problem that we did and try and take inspiration. Any idea? Any all right, So we're just going to go ahead and try and solve it together. So it's a quadrilateral. So that means, so it's a quadrilateral, right? So that means that the n is going to be equal to 4. So we're just going to plug it into the equation that we had in the last slide, which is equal to n minus 2 times 180, right? So we're going to plug in 4, right? So then that means that every single quadrilateral has to have 360 degrees of internal angles, right? But we already know the values of 2 of those angles, right? So the sum of all angles must equal to 360, right? So that means that 360 is equal to 90, which by definition, a right angle is 90 degrees, right? I want you guys to make that connection. So a right angle is 90 degrees, right? And then another angle with a measure of 52 degrees, and its other 2 angles are congruent. So that means that this quadrilateral here, it has an angle of 90 degrees, 52 degrees, and then these two, they would be equal to each other. So that means it would be 2x because you have 2 of those values repeated, right? Because there are 2 angles that are congruent to each other, right? And so then what we would do is we would just subtract 360 minus 90 minus 52, and we would set that equal to 2x because we have 2 of those angles. And so we divide 218 by 2, and it would give us 109 degrees as x. So here we have the measures of all of the angles, right? So we have one angle of 90 degrees, one angle of 52 degrees, and 2 angles of 109 degrees. All right, guys, do you guys understand? Is that making sense?
Yes.
All right. All right. So here are the types of triangles. I'm going to go pretty fast. So here we have a scalene. So all sides are different, and all angles are different angle measures, right? So, and then here we have an isosceles. What is that isosceles? So 2 sides are congruent. 2 angles are equal in measure. So we can see here. So each one of these lines, when you get into geometry, right? So each one of these lines, it basically just means that that these two, whatever line that the line goes across, that means that those 2 lines, they are equal in value, as in they are the same length. All right. And so whenever you guys see these different angles, right? So if they have the same amount of angle lines, then that means that they are equal to each other, right? So let's go over here to equilateral, right? So all sides are equal in length, all angles are equal in measure. So that means that this side, this side, this side, they are all equal and they are all congruent. And so then all angles, that means that this angle, this angle, this angle, they're going to be all the same. So one angle is a right 90-degree angle. So it's capable of trigonometry. So go over here. So let's see what the applications of trigonometry are. So for example, we can determine the height of mountains. We can see beauty in nature through trigonomic ratios, and we can even triangulate positions of super far away things. So here we have a star. It's at a 90-degree angle. It forms a 90-degree angle with Saturn, right? So we can go on. So something that we need to understand here is that can be we have similar triangles. I'm not going to really dig too deep into this. I'm going to release this into the curriculum. But what we just need to know is that the corresponding sides of similar figures are proportional. So for example, if I say that this triangle is similar to this triangle, right? So that means that all the sides are going to be proportional. The ratios of the corresponding sides are the same. So we're going to get into that a little later. But first of all, let's keep on going through here. So angle theorem. If 2 sides intersect, they form congruent vertical angles. All right, so 2 lines intersect. So for example, we have this line and this line. They intersect. And how many angles does this intersection form? Can anyone tell me? Anyone tell me?
Can you repeat the question?
How many angles does this intersection create?
2.
2. No. It creates 4. It creates 2 pairs of 2 angles, right? So this angle and this angle, they are equal to each other because they are congruent vertical angles. And now this angle and this angle, hold on, let me get the annotate tool. So this angle and this angle, they are equal to each other. And this angle and this angle, they are equal to each other. So that's just something that you need to know about angles. And this is very true in whatever. So if you guys look at my screen right now as I'm like sharing it, so if we create an intersection between these two pencils, right? Then this angle that it creates right here and this angle that it creates right here, they're going to be equal to each other because they are rigid lines. And we can manipulate this as much as we want, right? But that's never going to change because they're still straight angles. All right, so they also form supplementary angles that can be added up to 180, right? So here we have another intersection. So here, this angle would be equal to this angle. So x, you could say that this one is also x degrees, and this is also y degrees, right? But apart from that, we can create these supplementary angles. So supplementary angles are just angles that add up to 180 degrees, right? So here, because a line, technically, if you think about it radially, it forms 180 degrees. That's why when you say do a 180, you're just turning around because you're just facing the other way as you turn around the line, right? So they form supplementary angles that add up to the 180 degrees. All right. So this x degrees plus y degrees is going to be equal to 180. All right. So let's go on. If two straight lines cross two parallel lines and they intersect, they always construct similar triangles. What does this mean? All right. This one's kind of a doozy. So if two straight lines cross these two parallel lines and they intersect, they will always construct similar triangles as long as they intersect. So here we have an intersection point. These two are parallel, these two lines are parallel, right? And then these two lines, they intersect them, right? But the funny thing is that the two triangles that they create are similar. Now, can anyone remember what similar triangles mean? Who can tell me what it means to be a similar triangle to another triangle? It's okay if you don't know. You can just say, I don't know. Does anyone know what it means to have similar triangles? Literally anyone. All right. Does anyone have a suggestion as to what a similar triangle is?
Maybe it's like two triangles that look the same.
Well, we just if we go back over here, let me see, let me erase it. How do I erase it? All right, so if we go back here, right? So I went over the similar triangles, is over here. So here, let me see. Four, six, eight. Oh, four. All right, so if we erase all this, so corresponding sides of similar figures. So these two are similar triangles, right? So then that means that their sides are proportional and their angles are the same. That's what it means to be a similar triangle. You guys understand now? All right, I'm just gonna keep on going. This is a recorded thing. All right. So whatever this means is that it's so for example, in the triangles that this forms, right? So this one has a y angle, and this one also has a y angle. This one has an x angle, and this one also has an x angle. And this one has a z angle, and this one also has a z angle. But the sides that it makes are not the same length. So they are not congruent, but they have the same angle. All right. Does everyone understand? Please say something if you understand.
Yes.
You guys understand this? All right, perfect. All right. Please say something if you understand.
Yes.
All right, Setna, are you good with this? Do you understand this concept? Setna, are you in the? All right, I'm just gonna keep on going. So Yeah. Let me see. Let me erase. All right. So a triangle is drawn. So if a triangle is drawn using a new straight line parallel to the base of the triangle, it also forms two similar triangles, right? So a common way to portray points on triangles and therefore sides is to use letters to indicate the side by demarcating as such. So what I'm referring to right here, so for example, in order to demarcate that we are talking about the side, we just put a little line over it. So if it's DE, that means it's the line between DE. And so in order to demarcate that, we just put a little line over it. So DE is the side between the point D and E. AB is the side between the point A and B, and so on and so forth, right? This allows us to show its properties. So what this means, what I wanted to say here is that this AB, so if we look at line AB and put it over AD, right? That's going to be the same thing as if we put line BC over DE, right? So each one of these has a corresponding angle and a corresponding side. So that all equals K. So what that means is that AB over AD is equal to K. And if we want to find the side of AD, but we don't have the value of it, but we do have K, that means that we just multiply AD times K. So for example, let's say, Sarah, say which side is proportional to side AE?
And E, maybe it would be A and C.
AC, very good. Now, why is that?
I think it's because they're both going diagonal and it's like the same distance, but A and C seems longer than the distance it takes from A and E. So I'm not 100% sure.
No, because the distance is longer, being proportional doesn't mean that it's equal in length. It just means that it has a common ratio with the rest of these. Right?
Okay.
So AE and AC, and you're right, they both go diagonal, which is normally a very good indicator of whether or not it is proportional. So, for example, Setna, can you tell me what side is proportional to BC? Side BC. Right, Setna's not there anymore. All right, Aiden, could you tell me what side is proportional to BC?
Uh, uh, Z,
Excuse me?
Z,
What side? So the sides are all over here. So it could be AB, AD, DE, AC, or AE. It's not an angle. We're not talking about angles here.
oh, maybe, uh, AB
So we're
and
talking about BC here, right? So try to look for a side on this. So we're
BC and
talking about this.
DE.
No, wait. DE? Did you say DE? Did you say DE?
Yeah,
All right, good. That's the answer. Yeah, it should just be DE. But why is it DE, Aiden?
because how I got into is that it the V the DE was closer with the B and C.
All right, I'll take it. All right. So another property. So is Pamela still on this call? All right, Pamela's still on this call. All right. So this is formed. These are all properties that are formed by an intersecting line between two parallel lines. So opposite inner angles are equal. So what this is saying, so what this wants to say is that opposite inner angles. So the inner angles here are the angles inside the two parallel lines. So that means that this angle is equal to this angle, right? And this angle is equal to this angle because they are opposite and they are inner. angles facing the same way are equal, inner and opposite. So here we have an inner angle, and here we have an opposite angle, but they're facing the same way. So then therefore they have the same value. Opposite external angles are equal. So this derives from the fact that from this creates vertical angle pairs going through here, here, here and here, here and here and here, here and here, right? So those all create angle pairs. Sorry. Oh my God. Oh my God. All right. So there we go. All right. So these all create angle pairs. Now, opposite external angles. So because this angle is the same as this angle, and so therefore this vertical angle has to be the same as this angle, right? So then that means that, and that this angle has a vertical pair on this one. So that means that this one has to be equal to this one. Boom, like that. And adjacent angles are supplementary. So here we have adjacent angles. So who can tell me what adjacent means? Who can tell me what adjacent means? Can anyone tell me what adjacent means? Anyone, literally anyone at all.
Like a common side.
No, it just means that adjacent means touching. So if this angle touches this angle, does it not? This angle touches this angle, and this angle touches this angle, and this angle touches this angle. Why does it touch it? Because this angle has a line. It's made up of two lines. And then over here, there's an angle that's right next to it. So in this situation, these angles are adjacent. And so adjacent angles are supplementary. Who can remind me what supplementary means? What does supplementary mean? We can go back. What does supplementary mean? Can anyone tell me what supplementary means?
Angles that add up to 180.
Very good. Yeah. So, okay. So yeah. So they are angles that add up to 180. So that means that adjacent angles, so this angle and this angle, it will always add up to 180, right? And so that also means that the two inner angles on the same side, they will also add up to 180. All right. Pamela, how am I doing on time? Pamela.
You have like
All right.
8 minutes left.
8?
Yeah, because they have their break.
All right. All right. All right. I'm gonna go. All right, whatever. All right, I'm gonna go a little over. All right, so trigonometry. So this is a branch of mathematics. I don't expect you guys to like be super good at this, but I'm still gonna put everything. Can you erase, please? All right, so I'm still gonna put everything on these notes, and we're just gonna put everything out there. So trigonometry. So it's a branch of mathematics that focuses on the relationships between triangle angles and their side lengths. So specifically the ratios of right triangles and their side lengths. So this helps us find the two sides of a triangle. So let's go over the Pythagorean theorem. So basically what this says is that triangles are made up of two components. So they're made up of two legs. So right triangles. So right triangles are triangles with 90 degrees. So two sides that form the right angle, we'll label them A and B, and the hypotenuse. So the hypotenuse is the side opposite of the right angle. So it is always the largest or the longest side of the right triangle. We'll label it C. So in a right triangle, the square of the length of the hypotenuse, as in the square opposite of the right angle, is equal to the sum of the squares of the length of the other two sides, as in the leg. So if you got lost while you were saying this, so while I was saying that, so for example, we have these two legs, right? We have leg A and leg B, right? So if you take this side, right, and then you square it to make this area, so A squared, B squared, right? And so these two areas, if you add them up, it's going to be the same as C squared. So what does that tell us about the legs, right? So that means that the leg 1 squared plus the leg 2 squared is going to always equal the hypotenuse squared. So that means that the area of the square built on leg A squared, plus the area of the leg built on leg B squared is equal to the area of the square built on the hypotenuse. So how do we use this, right? So for example, let's focus on stuff right here, right? So we have a triangle, right? So the hypotenuse is of 5 units and one of its legs is a 4 units, right? So how would we do this? So we would set up the equation, right? This is always true for a right triangle, right? So we have a squared plus b squared is equal to c squared. Now we have the value of one of the legs, right? And we have the value of the hypotenuse, right? So we're going to substitute them in. So we're going to put 4 units as b and 5 units as c, right? And we're going to solve that out. That's going to be that. All right. And so using that, we're going to subtract 16 from 25, and that's going to give, so the answer to that is going to be x equals 9. X squared equals 9, right? And so then we're going to square root this because this has a x squared is equal to 9. We're going to set the square root on both of them in order to cancel out the square over here and to determine our answer. So that means that x is equal to 3. So that means that the a value, or x, over here is equal to 3 because we use this equation. Now, who wants to go ahead and read the question below? Who can go ahead and read it? Anybody just go ahead and read it.
If the wait, what did I say?
If a cable.
If the cable is trying to be, wait, hold on, because these look small on my screen. Hold on. Oh, drawn between the roof of 2 buildings, feet away, and with 19 feet in difference between their roots. What is the difference between their roofs? Bone long must the cable be? How long the cable must be?
Yeah. So what we have here, all right, Sarah, are you still with us?
Yes.
All right, so how would we set up this equation in order to find out the length of this cable right here?
Honestly, I'm still very confused on the top part. I'm trying to figure it out.
Trying to figure it out? All right, so what are you confused about?
Like when you're explaining it in my brain, I was just kind of hearing like numbers and I couldn't really make sense of it, like in that little yellow blob up there. So I don't really understand the question.
All right, so basically what this is saying, so we can just basically focus on the theoretical part. So let's say we have this triangle, right? Right, Sarah?
Yes, right.
We have this triangle, right? And so this equation is always going to be true for a triangle with a right angle right there. This is this one, right?
Okay.
So it's always going to be true. So no matter what these values are, right? No matter what A is, no matter what B is, no matter what C is, this relationship is always going to be true. So based on that fact, we can use these 2 known units in order to determine X, right? So that means that we plug this in. So let's say 4 units is equal to B and 5 units is equal to C, right? Do you understand that, Sarah?
Yeah.
All right, so that means that 4 units is equal to B. So then that means that we substitute 4 for B and 5 for C, right? So we have 4 squared and 5 squared instead of B squared and C squared, so, right? So then we square 4, that gives us 16, and we square 5, that gives us 25, right? And so in order to pass this over here, we're just going to subtract 16 from 25. Do you understand, Sarah?
Yes.
And so then that means that gives us this equation, right? X squared is equal to 9. And so because square rooting is the opposite of squaring, right? Right, Sarah?
Okay.
So in order to take this square out, that means that we're just going to square root both of the sides, right? And so then what's the square root of 9?
I'm guessing it would be 3 since it says X is 3.
It's 3. So that means that this side, A, is equal to X. Do you understand?
Yeah. So
right.
Down there, I guess it would be, so 13 feet, would that be B?
That would be B, yeah.
Okay. And then 19 feet part would be C.
No, because you have these legs, right? So that's something that you want to determine, right? So the 90-degree angle is between the 2 legs, always. So here we have a 90-degree angle. Do you see it?
Yes.
So then that means what would 19 feet be?
Can you repeat that? Sorry.
Well, so if 13 feet is A, then what is 19 feet?
B? Or is it
B.
okay?
It's B, yeah. So we can see that right here. 19 feet and 13. Or I don't know if we can do that. So it's 13, right? So that means that the hypotenuse is C. So we can just go ahead and do 13 squared plus 19 squared is equal to x squared, and we can just do the entire equation. All right. All right. So Pamela, how am I doing on time?
It's 4:45.
All right, we're just gonna do this. We're just gonna teach this little thing, and then we're gonna be off. All right. All right. So trigonomic functions. So constant ratios between the sizes of the legs and the hypotenuse. Actually, no, this might be too abstract. Or what do you think, Pamela? Should I just like finish it here?
Does the booklet have it?
I don't know.
You what?
Does the booklet have it? I don't know. I'm not sure if it does.
Oh, I mean, it's your call, and if it does have these questions, you can just tell them to
Yeah.
do it.
All right. This is fine. So we're just gonna go over this. So constant ratios between the sizes of legs and the hypotenuse. So basically, so whenever you have a right triangle, right? So given this, that means that there are going to be some constant ratios depending on the angles, right? For example, let's go to the first one, sine. So sine is the ratio between the length of the opposite angle and the hypotenuse. So basically, if we take that the angle here that we are always going to be studying is going to be this one, right? So that means that the opposite is the one that's opposite of the angle. So it's not touching it at all, right? So that's opposite over the hypotenuse. If you want to look at cosine, that's going to be adjacent over the hypotenuse. Boom, that's going to be this one over the hypotenuse. We're talking about the angle. And if we want to do tangent, that's going to be the opposite over the adjacent. All right, does everybody understand that? It's just kind of something that you have to memorize. And in order to memorize it, you guys can use SOHCAHTOA. So what SOHCAHTOA is just basically like a mnemonic. So SOHCAHTOA, yeah. So it's going to be sine because SOH. Sine is equal to opposite over hypotenuse. It's cosine because it's adjacent over hypotenuse. And tangent because it's opposite over adjacent. SOHCAHTOA. All right. So we can also, so let me go through one of these questions. We're just going to do this one question. All right. And then we're going to be off. All right. So if an ant is looking up to the top of a tree at an angle of 40 degrees and the tree is 14 feet high, what is the distance between the ant and the base of the tree? So one thing about the trigonomic angles, right? So one thing about trigonometry is that it's constant, right? So that means that if the angle is 40, then that means that the ratio between 14 feet and the distance between the ants and the tree is going to be constant. So that means that we can determine. All right. So first of all, we're gonna draw this out. So 55 degrees, x, and 14 feet, and we're gonna determine that what we need to do, because it's not using the hypotenuse at all now, is it? So it's gonna be, so we're gonna use TOA, as in tan TOA is equal to tan theta over which is opposite over adjacent. So we set the tan theta. So that means the theta here is going to be, what the heck? It's going to be 55 feet. All right, pretend this is 55 feet. I messed this up. 55 feet is going to be over 14 feet. So who can tell me what the next step of the operation here would be? What do you do next? Just looking at here. Who can tell me what we do next? Does anyone have any suggestions on what we should do next? If you don't, you can say I don't have any suggestions or whatever.
I don't have any suggestions.
All right. Sarah, do you have a?
Me either. I don't have a clue.
All right, you don't have a clue. All right, Setna, are you still with us? All right, Setna's gone. All right, that's fine. All right. So basically what you would do is you would just move the x over here, right? So you would multiply this side by x because it's divided on the other side. That means that x times tan 55 is equal to 14 feet. And so then that means that you would divide this side by tan 55 in order to isolate the x. And that would give you x is equal to 9.8 feet. All right. So that's going to be a lesson for today. We could go to the circle theorems, but there's some circle theorems on the homework. Please, 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 and try the homework. Try to do some of the homework stuff. And yeah, it will help you a lot with the homework. And I'm going to be posting this up on the Google Classroom because we didn't get to this today.